Hi everybody, it's Miss Lorenz. We're going to talk about lesson 17 right now, squares and cubes, and I'm excited to talk about perfect squares and perfect cubes. If you look behind me, right, like there, woohoo, my perfect squares and perfect cubes hanging up. So, I'm talking about the colored numbers that you see above my whiteboard, right? And so you guys should you should recognize those to some extent, that we have, perfect squares around us and perfect cubes. So maybe you'll start noticing them a little bit more. All right, you have to find 4 numbers that are perfect squares and 2 numbers that are not perfect squares. And so I'm just going to list the perfect squares through 100. And so 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, so 16 is a perfect square. 5 times 5 is 25, so 25 is a perfect square. 6 times 6 is 36. Excuse me. So 36 is a perfect square. 7 times 7 is 49, so 49 is a perfect square. 64 is a perfect square, that's 8 squared. 81 is a perfect square, that's 9 squared. And 100 is a perfect square, that's 10 squared. And of course we can keep going, but these are really important ones, and they're good ones to memorize. They're good ones to be able to recognize, so that if you see the number 64, for example, what's really great is when you finally get to that point where you see the number 64 and you think, oh yeah, that's the square of 8. So I know that 64 is the square of 8. I also know that 64 is the cube of 4. But we'll talk about perfect cubes in a minute. All right. Non-perfect squares. Well, look at all the numbers that are missing from our perfect squares here. So like 2 is not a perfect square. 3 is not a perfect square. 5 is not a perfect square. 6 is not a perfect square. 7. Okay, I'm going to stop because we could keep going forever. So any number that is not a perfect square here, essentially any number that we can't stack the cubes in a nice perfect square, hence the label perfect square, would be considered not a perfect square. So if a square has a side length of 7, then its area is 49. 7 times 7 is 49. If a square has an area of 64, then the side length is the square root of 64, which is 8. In other words, it would be a square that would have the side lengths of 8, because 8 times 8 is 64. Number 27 is a perfect cube, and you are to find 4 other numbers that are perfect cubes and 2 that are not. And so I'm going to do the same kind of thing I did with our perfect squares. 1 times 1 times 1 is 1, so 1 is a perfect cube. 2 times 2 times 2 is 8, so 8 is a perfect cube. 3 times 3 times 3 is 27, so 27 is a perfect cube. 4 times 4 times 4 is 64, so that's a perfect cube. 5 times 5 times 5 is 125, so that's a perfect cube. 6 times 6 times 6 is 216, so that's a perfect cube. I'm going to stop there. But you can see that it's the same idea. So look at how many numbers we're missing. So numbers that are not perfect cubes, well, 2 and 3 and 4 and 5 and 6 and 7, those are all not perfect cubes because we can't multiply the same copy of that number 3 times to get and build a perfect cube with that number of blocks. So do you see why they're called a perfect cube? You could take that number of blocks, in this case 27 blocks, and you could make a perfect cube out of it. You can't do that with 26. You can't do that with 25. You can do it with 8, and your cube would be a 2 by 2 by 2 cube. Ooh, it's kind of hard to draw in here, as you guys can see. All right. A cube has a side length of 4. What's the volume? Well, it'd be 4 times 4 times 4, which is 64. A cube has a length of 10. What's its volume? So we're just going to do 10 times 10 times 10, or 10 cubed, and we get 1,000 cubic inches. So if a cube has a side length of s units, what's its volume? Well, it's going to be s times s times s, which is the same as s cubed. All right, in number 3, we had to answer these questions making sure we include the correct units of measure. So a square has a side length of 10 centimeters. Use an exponent to express its area. So area would be 10 times 10, and so it's 10 squared centimeters. Or 100 centimeters square. An area of a square is 7 squared. So what's its side length? It's just 7 inches. An area of a square is 81 square meters. We use an exponent to express this area. The area would be 9 squared meters, or 81 square meters. A cube has edge length of 5 inches. Use an exponent to express its volume. It'd be 5 cubed inches, or 125 cubic inches. The volume of a cube is 6 cubed centimeters cubed. What is its edge length? So it'd have to be 6 if it's 6 cubed. 6 times 6 times 6, and these are centimeters. And then lastly, a cube has edge length of s. Write an exponent to express the volume to be s times s times s, or s cubed. All right. A square has side length of 4 centimeters. What's its area? Well, we're just going to do 4 times 4. So we have 16. These are centimeters squared. The area of a square is 49 square meters. So its side length is going to be the square root of 49, or 7 meters. A cube has edge length of 3 inches. What's its volume? We're going to do 3 times 3 times 3, also known as 3 cubed centimeters, or inches cubed, or 27 inches cubed. All right, and number 5, we're finally here. Oofda, it's a big problem. This is just a triangular prism, as you can see, and we had to find the surface area. So remember, a triangular prism is made up of rectangular faces and then triangular bases. So let's go to the rectangular faces first. We've got this face over here, and then this face down here. So like the ones that are meeting like this, those faces, those are both 1 and 2/10 times 1 in dimension, and there are 2 of them. So I just did 1 and 2/10 times 1 times 2, and I got 2.4. Now I'm going to erase that so we can see where I need to go next. And so, erase. All right, now what I'm going to do is do the bottom face, this rectangular face down here at the bottom. It's a tiny bit like wider, right? So it's 1.2, or 1 and 2/10 times 1 and 2/10, which is 1 and 44/100. So again, I'm going to erase that, and then I'm going to do the triangular bases. And so each of the triangular bases are half of the base times the height. So I'm going to do a half of, oh, I did the wrong base, you guys. Do you see that? Ooh, I'm so glad I caught that. All right, so I'm going to have to do a half of the base. A half of the base is 1 and 2/10 times the height is 8/10. So I'm going to have to do 1 and 2/10 times 8/10, which is 96/100. And then I'm going to have to take half of that. And of course, I end up with 48/100. There we go. And then so I just found the area of this triangle. Now I need to double that because there are 2 triangles, 2 bases. And 48/100 plus 48/100, or 48/100 times 2, we're back to 96/100. So now I need to fix my math down here because I've got my 2 and 4/10, those 2 triangular faces. And then I have 1 and 44/100, that's that triangular, or that rectangular base that it was sitting on. And then I need to have 96/100 here. And so I'm going to take what I have. My incorrect answer is off by 48/100. So I'm just going to add that. And you should have gotten 4 and 8/10 square meters. All right. I caught that before anybody else did. Remember, if you catch an error, you get a special prize. Thanks, guys, for listening.